Today we're going to be talking about sound and kind of how sound is a wave. So first question is, well, what is sound? Sound is a vibration. Something has to be vibrating to produce a sound. Furthermore, the vibration creates a disturbance, and we learn that waves are a disturbance in space and time. So the vibration causes a disturbance in the medium that the vibration occurs in. And we talked about medium and what a medium was. It's basically a solid, liquid, or gas. Um, we're going to spend a lot of time here talking about that sound travels through air because that's kind of the way we think about it, and it does. But just know that whenever I say air in this presentation, I could just as well mean water, or I could mean a solid too. So the vibration creates a disturbance in the medium, and that medium carries the sound. Sound has to have a medium to travel through. It's got to travel through air. It's got to travel through water. And because it has to have this medium, we consider the sound to be a mechanical wave. So what about sound traveling through space? You see all the time these, Star Wars films and things like that, and you can hear the explosions in space, and can that happen? Well, considering that space is a vacuum just means the absence of any kind of matter. There are no molecules in space. So there's no molecules in between you and maybe somebody else in space. And because there's no medium in space, it's not considered a medium, then a mechanical wave can't travel. So sound cannot travel through space, period. So even though that Luke Skywalker may have shot the TIE fighter and you can hear it in the movies, that can't happen in real life. There's no way. But a movie would be pretty boring if all you heard was silence. So that's why they do that. They just kind of take a little artistic license there. So now we'll talk about the ranges of sound. Sound is broken up into three classifications based on the frequency of the sound being produced. So when frequencies are in a range between 0 and 20 hertz, we say that it is infrasonic. Infra means before. So before you can hear it. That leads us to conclude that humans cannot hear these sounds. So if I produce a sound wave of 13 hertz, which I can do, I can't hear it. Even though it is a sound wave, humans just can't hear it. Things like volcanoes and earthquakes, and avalanches, things like that, they can produce sound waves of under 20 hertz, and we are not able to hear those particular sound waves. This is the way some animals communicate. Larger animals, whales, elephants, they can speak, in quotes, speak to each other through infrasonic waves. The next range of sound is what we consider to be audible noises. Audible means we can hear them. So anything between 20 and 20,000 hertz, the human being can hear. In a sound wave, we've talked about, or any wave, we've talked about amplitude and frequency, things like that. Well, the amplitude is synonymous with the volume. So a larger volume will mean that the sound wave has a larger amplitude. The frequency relates to pitch. So the higher the frequency, the higher the pitch, the higher the sound. That's why girls typically have higher pitched voices than boys do, because their vocal cords, girls' vocal cords are shorter, and so the shorter string or shorter chord will vibrate at a higher frequency, so you get a higher pitch. We talk about decibels all the time. Decibels are a measure of sound's power. Okay, a lot of times we equate this with volume and how loud the noise is, but you can have a really, really loud noise and be a pretty far distance away, and it doesn't sound very loud. So we measure the decibels, and we measure that according to where we're taking the measurement. So if I'm, 30 feet away from a noise, it's not as loud, and the decibels aren't as large as it would be if I was 1 foot away from that same noise, because of the power of that noise. Here is a little chart, and I'll let you look at that for a minute with different sound levels, different decibel levels. You can barely hear something at about 10 decibels. In a busy office or a classroom full of people working, where people are talking at fairly normal volumes, but maybe somebody's typing, people are typing on keyboards and people are having conversations, you're talking about 60 decibels. However, you go near a train, or you run some power equipment like a lawnmower or chainsaws, you're up here in the 110 decibels. Rock concert, 110. So if you've ever walked out of a rock concert or finished cutting grass or something and didn't have earplugs, and you come out of there into a quiet place and your ears are ringing, that means that you have done some permanent hearing damage, which is not good, because when you damage your ears, that's kind of irreversible. We can't do surgery on your ears to fix it. So think about listening to your iPhone, your music from earbuds. You're listening potentially up in this level right here, which is not real good for your health. I always say that if I was smart and if I had a little bit of money, I would invest in a hearing aid company pretty soon, because within the next 20, 30 years, your generation of people who listen to the music all the time in their earbuds are probably going to need hearing aids. I don't have any money, so it's hard for me to invest in things, but maybe you'll be smart enough to do that. Maybe you'll be smart enough to actually listen to your earbuds at reasonable volumes. I fall in this category too. When I'm cutting grass, I absolutely listen to music. So, I'm doing some hearing damage to myself as well. So just keep that in mind whenever you do listen to loud music. I'm gonna let you do this. I'm not gonna run this in this video, but I'll make this slideshow available for you, and you can listen to this. We're gonna do this in class too, but if you do this at home, make sure your speakers are on, but not too loud. And you probably want to get your dog out of the room, because this may really mess with your dog. Your dog's probably not going to like it very much. But it's a video that goes through the entire spectrum of sounds from 20 hertz to 20,000 hertz, and you can listen to it, and you can listen to when you're able to not hear that sounds anymore. All right, the last range of sound is called ultrasonic. This is what an ultrasound is. These are sound waves that are produced with frequencies above 20,000 hertz. And again, humans cannot hear these, but they're still there. We use it a lot of times for medical imaging, dog whistles, because dogs can hear in a range over 20,000 hertz, and humans can't. So we blow a dog whistle, and that's why we can't hear the dog whistle, but the dog does respond. The reason that we use these in medical imaging a lot of times, especially with babies, is we don't want to use x-rays. We can get the same image right here with an x-ray, but x-rays are potentially damaging to tissue, especially developing tissue of a fetus. So what we don't want to do is expose a baby to a lot of radiation, where we can end up damaging its tissue, and we could give the baby cancer before the baby's even born. With a mother, the same way too. A lot of expecting mothers will get an ultrasound nearly every week in the last part of the pregnancy. So we got to make sure that we keep babies and moms both safe and not as exposed to X-rays. So we give them an ultrasound, which is completely safe. Here you can see the hearing ranges of different animals. So humans fall in the range somewhere between 20 and about 20,000 hertz. Dogs can hear lower than 20. They can also hear higher than 20,000. So your dog whistle falls in here somewhere. Dolphins have pretty good hearing. Frogs, not so good. They have a very narrow range. So, all right, the speed of sound. It's very common for students to make the misconception that higher frequency sounds travel faster than lower frequency sounds. Well, guys, it is just a sound. And sound waves can't travel faster than sound waves. That doesn't make any sense. All sounds travel at the same speed, and that speed depends on the medium that the wave is traveling through. Typically, sound waves are slowest in gases, then liquids, and they travel the fastest in solids. So keep that in mind. It also has a lot to do with temperature too, but we're not going to worry about that. So an example is the speed of sound is faster in water than it is in air. That may not sound right to you, but it is true. It about 5 times as fast. Now, if you go down into a pool and you can hear the noises in the pool, it doesn't mean that you can hear them any clearer than you can in air. It just means that you hear them, they get to your ears faster than they would in air. We're going to approximate the speed of sound as being 340 meters per second through the air. That's 700 and something miles per hour, 760, I think, miles per hour. So it's going pretty quick, but ultrasounds travel at 340 meters per second. Audible sounds travel at 340 meters per second, and so do infrasonic sounds. So always think of sound as being the same, whether we can hear it or not. It travels 340 meters per second through the air. This is what I said earlier. All sound waves, no matter what their frequency, travel at the same rate. All right, so what is supersonic? Don't get supersonic and ultrasonic confused. Ultrasonic just is talking about the frequency. Supersonic is actually talking about the speed. So a supersonic object is traveling faster than the speed of sound. So sound cannot be supersonic. Okay, sound can't travel faster than sound. But what can? Bullets can. A whip can. And certainly jets can. And if you've ever fired a bullet, you hear a little crack after it. That's the bullet breaking the sound barrier. The crack of a whip is actually the sound barrier being broken. And jets, when they travel faster than 760 miles an hour, which is 340 meters per second, they produce a sonic boom. It's actually a pressure wave that turns into a shock wave. And it also creates this condensation cloud. It has to do with the air pressure, and the air around in this cone right here is unable to hold moisture because of the pressure difference, and it creates this cloud of water vapor. And so that is in the same shape that the sound wave being produced is, the sonic boom. All right, so that is all about sound. Hope you learned something.